Alright, you guys, these are the notes for the Monday, April 22nd. So the first thing we're going to do is figure out what our formula is, our exponential growth formula. F of x equals a 1 plus r to the x power. Okay? And in this situation, a right here is your initial amount. R is the rate of growth, and x, or t, is the time. Okay, so as we talked about, when b is greater than 1, it's a growth. And obviously, if you're adding 1, this is going to be bigger than 1. So we've got the original value of an investment is $1,800. The value increased by 7%. This is going to be the same as 0.07. That's a percentage. And write the exponential function to model the situation. So that's going to be f of x, or t, 1,800 times 1 plus 0.07 to the x power. So if we add that together, 1,800, 1.07 to the x power. So here's your equation. Then if you're finding the value of the investment after 15 years, the amount of time that goes by is going to be 15. This can be either x or t right here. That can be either x or t. So if you calculate f of x equals 1,800, 1.07 to the 15th power, you just plug that into your calculator. Is this going to work? Nope. Hopefully you've done it by now while you're waiting on me. You're going to do 1,800 parentheses 1.07 in the parentheses raised to the 15th power. And you get 4966. So the amount of money is 4966 point, and we're talking men here, so you want to go to the cents. Oh, sorry, yeah. So that is going to be your value. All right, so an investment of $1,800 after 15 years would be that amount. Same with this one. You've got f of x, 972 students. Since the number has increased, so we know it's a growth, by 0.15 each year. Write an exponential function to model the equation. So your a value is going to be 972. 972 for a. Your b value is 1.5%, which is the same as 0.015. You move that decimal point over 1, 2 when you're talking about a percentage. So your equation is the same as this, except for now our b is 1 plus the rate, because we're increasing. So f of x, 972, 1 plus 0.015 to the x power. Now we're trying to find the number of students enrolled in 2014. So from 2002 to 2014, that's 12 years. 972, 1.015 raised to the 12th power. Oops. And that's going to give you a total of 162 students. Of course, your students has to be a round number. You can't, oh goodness, you can't have it be a decimal because it's students. You can't have a 14th person of a student. All right, now we're talking about exponential decay. So that's your growth. Decay is going to be very similar. I think I might be a little too close. You've got f of x equals a 1 minus r to the x power, or to the t power. A is still your initial value. R is still your rate. And in this case, it's going to be your decay rate, because it's going to be less than 1. And then t is your time, or x is your time. Okay, so now one of the examples is the investment of $1,200 is losing value or depreciating at a rate of 4% each year. What is the exponential function to model the situation and find the value after 9 years? So our initial amount is $12,000. The depreciation rate is 4%. This is very similar to your car project. And then the time is going to be 9 years, which is x, or your exponent. So my equation is going to be 12,000, 1 minus 0.04 raised to the x power. All right. So you've got your A, your B with your rate, 1 minus your rate, to show that it's a decay, show that it's losing value, depreciating, raised to the amount of time over time. So this is going to be 12,000.96 x. This is your equation that you would use for your car, right? This is what you're getting for your car. Your depreciation rate is this. Make sure you don't confuse the two. Then when you plug this into your calculator, you're going to get 12,000 times 0.96 raised to x is 9. Your answer is going to be 8310.41. Oh, sorry, 8310.41. And that is this equation with your decay rate raised to the 9th power for the number of years. All right, hopefully that is helpful. I'm going to let you guys do this one. Pause the video, do this one, and I'll give you the answer. So pause it. Yes, pause it. If you haven't already done it, do it now. All right, so the answer is 19 524.63. Because the equation would be f of x equals 3,500.92 to the x power. Then when you plug in from 2008 to 2015, that's going to be 7 years. So f of 7 is going to be that amount. Alright, so now we're talking about compound interest. And this is basically occurs when the interest is calculated on both the principal amount and the accrued interest. Okay, so if you were earning 10% interest and day one you had $10, day two, 10% of $10 is $1, right? Times 1.1 is going to be $11. Now, if you earn 10% on $11, the next day you're going to have times 1.1. The reason I'm getting 1.1 is I'm taking the 1 plus the 10%, 1.1. That's where I'm getting that 1.1. So the next day I'm going to have $12.10. Then the next day, if I get another another 10% of interest, that amount times 1.1. Now I'm up to 13.31. And do you see how when I earn interest on the interest, it's going to increase at a faster rate than if I'm just earning 10% interest on $10 over and over and over again. Now my interest is earning interest. Okay, so that's what we're talking about here. The formula for this is A equals P1 plus the rate divided by N times T. So here's what these all stand for. P is the principal. Principal amount. P is the principal amount, so that's the same as the initial value. R is the rate, the interest rate. N is the number of times it's compounded over a year. And then T again is the amount of time, or years. The time is always in years. So if it's for 6 months, then the time would be 1/2. All right. So Laura deposited $12,000 into the account. So the initial amount, the principal amount, let's put P, is $12,000 into an account that earns 8% interest. So the rate is going to be 8%. How much will she have in 5 years? So the time is going to be 5 years. Compounded quarterly. How many times a year would that be if it's compounded quarterly? quarterly means 4. Quarterly, same as 4. So n is going to be 4. So we're going to take this and put all these into our equation right here. So A is going to equal 12,000, which is our principal amount, times 1 plus, now this is 0.08. So 0.08 is my R, divided by n, which is 4, raised to the n, 4, times the t, or the x value, 5. All right? And then you can rewrite that as 12,000 and 1 plus 0.08 divided by 4 should give you, 1.02 to the 20th power. Once you plug that into your calculator, you're going to get 12,000 times 1.02 raised to the 20th power. A is going to equal 17,831.368, but since we're talking about money, I'm going to round it to the cents. All right. Let's go down to here. I don't let you guys put these in the calculator, but I will tell you that the p-value would be 25,000. The rate is going to be 4.50, so that's 0.45. The time, it's a 6-year loan, and it's compounded monthly. Well, monthly in a year is going to give you 12. So n is going to be 12. When you put that in your equation, 25,000 times 1.00375 raised to 6 times 12 is 72. Now, I'm not telling you to skip all this stage. I'm just skipping the stage in the interest of time. But I would suggest you write it down completely and the way that you need to write it down. I'm just doing this because I don't want to make this video longer. This is going to, when you plug all that into your calculator, you're going to get 32,732.58. So see if you can do 7, 8, and 9. And pause the video, see if you can work 7, 8, and 9, and then then come back and I'll give you the answers. So do all three because I'm going to give you the answers to all 3. Alright, here is basically this is a 3, this is a 0. Those are your equations. If you got one wrong, double check your equation first and then retry it. Here are the answers next, so pause it if you haven't gotten those exact equations. I really want you guys to do this on your own. Alright, so for number 7, this should be your answer. For number 8, it's actually asking you the interest. So even though you're getting this amount when you plug it into your equation, it doesn't want the entire amount. That's your principal plus your interest. It just wants the amount of interest, which is 24 98. And again, same with this one. How much interest will you earn after 20 years? The interest earned is going to be the 1366.35 minus 750, which is 616.35. So this is your answer. All right, hopefully that's helpful.